Hello guys, today we're going to take a look at another one of these old RC vehicles. This one is sort of a big stunt vehicle, it has two big wheels, and we're just going to show you how you can control something like this with one of our new control boards. So this will be another little project to create some more example code for the RC Tractor Guide library. So this was just another cheap RC vehicle. It had this kind of arrangement for the controls, which pretty much had a big row of transistors to control your motors, and I guess it was very high or very low frequency signal here because the antenna is quite long. But that's kind of all there was to it. I don't think there was any speed control. You just had full power forward or full power back. When we switch in this control board, we should be able to get some speed control from it. You can see a hole in the top here, which is where I think I planned to put an antenna like this, because at one stage I was thinking I'd try and make a robot out of this, but in reality I never had the time to do it. So we might as well just use it to get another example code for our control boards here. The hard work's all done, it's taken apart already, so I'll just assemble it now. All we're going to need to do yet again is just put the bound connectors on the motors, and we have some wires here for LEDs, and they are going to be like beacons. They flash on these two green sections here. So it should be pretty straightforward. We have a battery, we have a switch, just a matter of connecting everything up. Okay, well I have the wiring pretty much sorted here. When I wired it up first, we had a problem with the noise from the motors causing everything to cut out, which is what we seen on the cheap Chinese John Deere tractor. I was able to add some 100 nanofarad capacitors between each terminal of the motor and the casing of the motor. That hadn't been on the motor. There already was one across the terminals. That helped. I also added a few capacitors just to give it a little bit more charge, so that it smoothed out the each pulse that was being sent to the motor drivers or sent to the motors, and that kind of worked, but you'd still, if you pushed it quickly, you'd get it to cut out. So what I did, because this is only a kind of a once-off thing, it's not a big deal, and this is only happening because we have these big brutes of motors. If we were using N20 motors or something like that, it wouldn't be an issue, but for this kind of thing, what I did was increase the PWM frequency to its maximum. I think that's in the kilohertz. So you might notice normally when we move the motor slowly, you can hear the PWM, and that's because it's at something like 400 or 500 hertz, and you can actually hear that noise, or you can hear that frequency. it's now at like 64 kilohertz. So I'll just show you. If I push this slowly, you could hear no noise until the motor started to physically move. That's because it's switching at something like 62 kilohertz, or maybe it's 6 kilohertz. I'm not sure, but the frequency is above the audible range, so you can't hear it anymore. But you can see in there the lights are flashing pretty quickly. That is the same setting as the beacons on all of the vehicles I have. So normally it's like flash, 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 flash. This is obviously flashing very quickly, and that's because when we increase the timer to get the PWM faster, it's the same timer that's doing the delay functions. So now the delay functions are happening much faster than they should be. So normally your millis function overflows every 1 millisecond, so you can count milliseconds. But now the prescaler has changed. The frequency is way faster. So instead of it counting a millisecond, it's counting a fraction of a millisecond. But that doesn't really matter because, well, this is only a once-off thing, so we don't have to really worry about that. But we appear to have our motors working, and I can see they're going in opposite directions when I push forward. So this one is going in this direction, and if it's doing that on the wheel, I think the wheel will be going in reverse, so I think I need to swap this motor around. So if I do that, the two motors are now spinning in the same direction. So I don't know if I can get an example. Okay, well, I can't really hold that there, but I think they're going the wrong direction, so I'll spin them both around. Okay, well, until I put it together, it's very hard to know what exactly is going to happen, so I'll just continue reassembling it, and hopefully it'll work out for the best. Okay, I have it back together now, and at slow speeds it works alright, but if you give it a bit too much throttle, it tends to like rocket forward. I think it's kind of the noise from the motors is sort of messing with something. It might be the motor driver because the lights keep flashing like you would expect, and if the processor had frozen, you'd imagine they should have stopped flashing. So I'm not quite sure what's causing that. Maybe the battery is gone a bit flat as well. That's another possibility, but I'll show you at slow speed anyway. So as you can see, not the easiest vehicle to control. Then again, it wasn't too easy to control with its original controller either, because it rocks so much. But I'll try and show you now what happens with when you accelerate quickly. You can see to be lose control to some extent. So I think that is noise somehow affecting it. So if you're kind of hard on the throttle, you seem to get sort of dead spots in the control. Or also sometimes it'll just rocket forward. So there, for example, it just shot forward. So I'm not really sure how to solve that problem, but I think there's not much more I can do with it. If the next owner wants to try and figure it out, they're more than welcome to. Like I said, this is going to be another one of the ones that goes on the eBay page. We have the sample code from it, so the next owner can try and develop the code a bit more if they want, or they could just take the board out of it. You're pretty much only going to be paying for the boards anyway. So we didn't get exactly the control we wanted, but at some point I just have to call quits on some of these projects and spend more time on the really interesting stuff, the vehicle builds that we're actually interested in. This stuff's great for developing code and things like that, but sometimes you just have to put an end to the project. So I hope you enjoyed watching it anyway. It gives you another example of how to wire another different type of vehicle. If you did like it, don't forget to hit the thumbs up button, and if you're not subscribed already, make sure to get subscribed. And yeah, I think that's pretty much everything for this video, so thanks very much for watching. Thanks very much for watching, guys. If you liked the video, please hit the like button, and if you don't want to miss out on the next video, click the subscribe button below and get the bell on for notifications. A big thanks to all our patrons, sponsors, and you guys buying the PCBs for your own projects. That all helps to support the channel and keep the content coming. And speaking of content, there should be links on the screen now to a few more videos if you want to keep watching. And if you go to the channel homepage, you'll see that there are plenty of playlists there to check out. But that's all I have for today, so I'll see you in the next video.